Hello, buenas tardes, good afternoon, amigos de Lima, Perú, Java User Group. Estamos hoy día muy contentos porque tenemos a Marcus Hellberg, que es Java Champion, Developer Relation Expert, Board Member. Él es Manager in Vaadin, y tenemos el honor de tenerlo aquí con nosotros. Carlos nos va a apoyar también con el
VP,
tema
¿no?
VP en Vaadin, y Carlos también va a ayudarnos para poder hacer la traducción en inglés, porque Marcus habla muy poquito, a little Spanish. ¿Ok? Welcome to Java User Group, Marcus.
Thank you, gracias. Buenas tardes a todos. Soy Marcus. Vivo en los Estados Unidos, en la Sierra Nevada, montañas de Nevada. Y I'm very happy to be here. I have to, unfortunately, switch to English for this. Otherwise, we'll be here for about 4 days before I remember all the words needed. So hopefully we have one language that we all share in common, and that's Java. So I think much of the important stuff will be in code and in examples. So hopefully, if not, Carlos, maybe you can help in the chat and give some clarification there. So
Right.
So if everyone is ready, maybe we can get started. I will share
Sure.
my screen here. Let's see that I get my right screen, that one. And made that. Okay. And then just give me a thumbs up or down if you can see that.
Thank you, Marcus.
All right, very good. So today we are going to talk about practical AI in Java. So I've been going around the world talking about Java for, I don't know, almost 2 years now. And at first it was really cool to people, just the fact that you could call AI from Java. And there was a little bit of novelty in just being able to say like, hey, give me a bad joke about X, Y, or Z. But I think we've gotten past that, and AI has really become pervasive in much of what we do and kind of everything that we do. So in this talk, I want to really talk about the practical details of using AI in Java, doing actually useful things and in the types of applications that we're building. So of course, I don't know exactly what you guys are doing, but we at Vaadin are especially working with companies who are building enterprise applications. These aren't the cool applications that you find in app stores. These are the back office applications that run businesses. They're the ones that actually make the world go around and make all the money. So they're very important. And the other thing that I've noticed kind of working with these companies over decades is that there's a lot of inefficiencies in them. There's a lot of people in the world who are sitting in cubicles doing more or less meaningful manual work that I think we could, with the help of a little of AI kind of used in the right way, we could really kind of streamline and kind of make these workflows more efficient than they are today. So I really want to take a look at how we can use the AI tools that we have available today in a language that we all like, which is Java, and how we can actually solve meaningful problems. And the right way to use AI isn't always necessarily to use it for everything. I think the AI hype wave has kind of as a side effect kind of caused us to also try to use AI for all kinds of stuff where it really doesn't help all that much. So there's really nothing wrong with just plain old code. So if there is a thing that you could solve in just plain Java, it's probably going to be a whole lot more efficient, definitely a lot more deterministic, and kind of easier to reason about in the long run if you're able to do it. But at the same time, there are so many things that we can do today that just 2 years ago, if somebody asked you to do them, you'd be like, no, that's impossible. Like, I can't do that. And now it's like, well, give me an afternoon and I'll have it done. So it's really remarkable what we're able to do today that we weren't able to do just a few years ago. So let's take a look at what that actually looks like. So this talk, I really want to show that AI is much more than the kind of regular chat interface that we see in so many tools. Of course, like ChatGPT or Claude or any of the tools are kind of very versatile. You can use them for pretty much anything. But I think the power of AI, and especially these kind of regular applications that we're building aren't necessarily always going to be just a chat interface. They might be very specific AI enabled or enhanced actions that happen just as normal parts of the application running. So the user might not even realize that they're using AI under the hood, whereas it allows us to do things that we wouldn't have been able to do in the past. So that's something that's going to be really cool. Now, this talk is going to be a lot of just looking at code, but I want to just go through a couple of practical details before we get there, just so we're speaking the same language as we're looking at the code. We're going to be working with a library called Spring AI in this talk. We, as Java developers, are in a really lucky position where we have two really great libraries for working with AI today. So we have Spring AI by the Spring team, which if you've ever used any other Spring tools will feel pretty familiar because it kind of reuses a lot of the same patterns and kind of ways of working that you're already used to in Spring, and things are auto-configured the way that you would expect. Then there's also the LangChain for J project, which started out as a port of the Python LangChain project, but since then it has pretty much taken on a life of its own, where it's taken on a lot of influences from other libraries, a lot of kind of novel innovations, thanks to a really kind of big community in the Java world that's contributed to it. So both are really good. In this particular talk, I'm going to use Spring AI, but there's really no reason you couldn't use one or the other for everything that you see here. So if you're unsure, just take a look and see which one feels more kind of your thing. Before we want to start building apps, we need to understand how to speak to an AI. And the way that we do that is through prompting. I think, like, if you've existed on the web for the past several years, I mean, you've heard of prompt engineering. It's not entirely new to you as a concept, but it's good to just go through a couple of the basics just to understand how we can kind of be most efficient in discussing with the AI in order to kind of give it the most effective instructions. So in a way, prompting is a way of programming because we're trying to somehow make a computer do the things that we want it to do. The only difference is that there aren't really any fixed rules and the output isn't deterministic. So it makes the whole process a lot more interesting. And a lot of it is really kind of comes down to trial and error, where you have to like really try different approaches and see what works. So the first thing that's really important is to try to be as specific as possible when you're asking questions. So say that we asked an AI to write us a function to sort data. If we didn't specify anything else, it might do some crazy stuff like return PHP, which is obviously not something that we would ever want to see. So if we wanted to be more specific, we could say like, hey, write a write a function in a language, TypeScript or Java in this case, and sort by these things. And I want the interface to look like this. And at this point, you're going to get something that's going to be much closer to what you're actually wanting to get from that AI. Try to give it some structure to work with. It's going to help it kind of think in the same way that you're thinking about problems. So if you say, hey, check my code for bugs, that could mean anything. Like, it doesn't necessarily understand what exactly you're interested in understanding. Whereas if you give it more specific pointers, like, hey, I want you to look out for performance issues, security vulnerabilities, this and that, and format the response in this way, it's going to, again, understand much better what you're saying. So all of this really comes down to communication. Like, the more specific and clear you can be in your communication to this AI, to this LLM, the better it's going to be. Give kind of context and constraints as much as possible in terms of like what language or coding style you want it to use. Are there any kind of validations that you want to make sure that happen? Is there any other requirements that need to be taken care of? The more you can kind of give context to the discussion, the better decisions it's able to make. So it's, again, all of this kind of boils down to just being specific and clear. One thing that really helps it sometimes, if it's kind of a more difficult task, is to give it some examples. So you can first give it all the kind of context and examples that you have, but then you can give it some like clear examples, like, hey, if I have this input, I would like to get this output. If I have that input, I want to get that output, and then let it go. So once it kind of locks onto a pattern that it sees, then it has a much easier time to kind of keep doing the same thing. So sometimes if you're struggling to get it to do what you want exactly by just explaining in words, giving it 1 or 2 examples of what you actually mean can make a big difference and kind of the output of that. If you're trying to do something that's really complex, it might be easier to kind of break that down into several kind of smaller subtasks, very similar to you, like as a person, like if you had to build the entire project in just one sitting without breaking anything down into smaller pieces, it would be very hard to like try to keep all of that in your head and kind of understand all the moving pieces. Whereas if you start with, in this case, kind of building a model schema and then an endpoint for that, and then a login endpoint, and kind of taking one logical piece at a time, it can be easier for it to kind of get there. And also you can ask it to kind of reason step by step. This is another kind of trick we can use to help the model kind of think aloud before it does something, and that really improves its performance. Sometimes it's also helpful to kind of give it some context in terms of kind of who it is or like how it should behave. So if you were to say that, hey, hey LLM, you're a senior Vaadin expert, and I want you to answer these questions, that the fact that we're saying that at the beginning of our prompt is going to help the kind of probability of the future tokens that follow from that point on forward in the LLM to be more in the general space of Vaadin, because we've kind of instantiated it with this notion that we want to be talking about Vaadin. And perhaps the most important thing is that very rarely, if ever, do you get the kind of most optimal and best prompt on the first try. So a lot of times what I end up doing is I'll use a tool like Claude Desktop or ChatGPT and iterate on the prompt with just some like sample data in my prompt and see that I get it working. And then once I'm happy with kind of that, then I can move it over to my app if it's a bigger thing. Or similarly, if I'm within my app, I might try 10 different variants of a given prompt before I actually am happy with it. So I think that's enough kind of background story, and it's time for us to jump into some code and kind of look at some actual examples. So I'm going to work in a project here, and I'm going to share the link to you after this, so you don't need to try to take copious notes or screenshots or anything like that. You'll get all the code, so just pay attention more to what we're doing here. So the project that we're in is it's a Spring Boot project. So we're using Spring Boot, and I've added Vaadin there as a UI library. We have the Spring AI OpenAI Spring Boot starter. So that's a OpenAI specific dependency. If we wanted to use, say, Anthropic, we could change OpenAI to Anthropic here. All the code in our actual project would stay the same, but instead we're using a different provider's models. Then in order for this to work, I've defined some things in my application properties. So the most important thing is to define your API key. Without that, you will not be able to call any of these external APIs. We're going to talk about local options later on, but for now, I defined an API key, which model I want to use, and then I also defined which model I want to use for text embeddings. We'll get to that in a bit. But if we take a look at the kind of basic building blocks of how would you call an LLM to have it do something for you, this is something, it'll look something like this. So we're going to construct a new Spring AI chat client. The way we do that looks very similar to constructing a new Spring REST client or anything else. So you create a builder and then you call build on it. We can take a look at some of the options that you can pass in there, but just as the simplest possible form, you just call builder.build and you get a chat client. Then in this case, I've generated a little layout here, a vertical layout that has message input. That's what we have here on the bottom. And then we have this layout of messages that we keep adding to. So the important or interesting thing here is that we have a listener on this input saying that whenever we submit, we get the event, we get the value from there, which is the user's input. We create one markdown message with that, and then we create another one that we can use to then stream the bots to message to. So the call itself looks something like this. So you take the chat client, then you say that you want to create a new prompt. You say that here's my user message. That's the value from the input submit event. In this case, I'm going to call the stream API, which will return the values from the LLM as they're getting generated. We could also use the call API, which would just be a blocking call, and we would just get a string back, but that's not as nice as a user experience. And then we call content to get a flux of strings. So essentially just a stream of strings that are getting returned. And then for each one of those, we append the markdown to our component. So if I say something like, hey, here, it should hopefully respond here. And just to kind of circle back to the prompting we were talking about earlier and the importance of A, giving context, and B, showing how to do that, let's say that I want to ask this AI how to create a new button. How do I create a new button? So I'm going to ask it that. Right now, because it does not have any context about what we want to do, it has determined that the most likely thing that we want to, wow, that's not super helpful. Okay, so it's saying that we should probably use HTML and CSS, or maybe JavaScript, or maybe React, or Swift UI, or Android, or anything. So because it doesn't know, it's just like, well, here are 5 different ways you could do it. I don't know. So one way we could actually tell it how to behave is by giving a system prompt. So this is essentially us telling the LLM how it should behave in the context of this discussion. So we can give it a default system prompt like this, and here we can then return something. So we can say you are a senior Vaadin expert. Answer the following questions. Yeah, oh, that seems about right. I have hot swapping enabled, so whenever I make a change here, it's just going to automatically reload, so that way we can move fast. So if we now, given this new context that it's a senior Vaadin expert, and answer the following questions, let's say about Vaadin in a friendly manner. So now we're giving it some context on what we're actually interested in knowing. So if we now ask, how do I create the button? This should hopefully now be kind of grounded in that specific framework. And it is, so we can see that, okay, yes, here's how you do it. So you extend from a vertical layout, you import the Vaadin button component, and you add a click listener to it. And this is exactly what we wanted. So just by being more specific and giving it the context it needs for understanding what we're trying to do, it's going to have a much easier time to do it. Now, this is still that chat interface that I was talking about, and it's super useful, but it's also one of the more difficult ones to actually get right, because it's in one way the most kind of, or the one that you have least control over, because the user can really type in almost anything here and ask it to do anything. So it's harder for you to kind of optimize for that. So let's take a look at some more specific examples where the user might not actually know that there's an AI behind the scenes doing all this work. So in the next example I have here, we have a document analysis bot. So what I have here is a markdown file that contains the meeting minutes from a hypothetical sprint planning meeting. And in this case, I want to allow the user to either summarize that meeting or to identify the action points that were kind of taken during that meeting and give them to me. So you could see that this would be useful if you have a lot of meetings and you just wanted to maybe automate this, and after a meeting you would send these over to a Slack channel or something. So in this case, we uploaded our file. We said that we want it summarized, and we get some pretty kind of easy to read summarization out of this, like, I think 5-page document. We get kind of reasonable things. So if we take a look at how we did this, we have 2 different system messages now because we have the 2 different modes. So we have one for summarizing the message. So in this case, we're telling it that we want it to summarize. It should be short as possible while remaining clear and informative. Use bullet points, so we want to have a very skimmable list of things, and avoid including minor details on this unless they're crucial. So we're really we're being much more explicit than we would ever be to a normal person who has a kind of innate understanding of what a good summary is. So we need to be very explicit sometimes to get a good summary. And likewise, we have another one for getting the action point. So here we want to identify clear, specific, actionable things that are assigned to a person. They should have a date when they should be completed, and we should avoid things that are already done. So the actual code here, and kind of the interesting thing is, like, we handle the upload, we parse the file. In this case, I think we're using Apache Tika. So essentially, it doesn't matter if it's a PDF or any kind of Word file or Markdown file, it's going to work. The kind of interesting thing here is this part here. So again, we're using our chat client to create a new prompt. In this case, we're not using a default system prompt because we want it to change on the fly. So in this case, we check which mode has been selected. So if it's summarize, we're going to use the summarization system message, otherwise the action points message. So we tell it how it should behave, kind of what are its instructions. Then we give it the text content to summarize. Then we call, and in this case, we're using the call, not the stream method. So you can see that we're getting a string back instead of a flux of strings. And once we have that, then we add a new Markdown component here, which displays that here. So again, we can take a look at how that's different if we now were to use the identify action points here instead. So you can see that this is taking actually a while, so it might have been nicer for me to use the streaming API and actually output content as it's getting generated just out of a UX standpoint, but it doesn't matter. So we can see that, yeah, we have edit permissions assigned to Mike, due by this day. So this is a really kind of good actionable list for us to kind of go through with the team and make sure that everyone knows what's expected of them. So again, so if we just kind of think back at the functionality here, like, we're very much relying on an AI to do the work here. But if you're kind of putting yourself in the shoes of the user of this system, they might not understand at all that there's an AI behind this. And I think that's kind of a key thing to notice here. I'm trying to kind of give you ideas of all the small things like button presses and things that might actually benefit from having a little bit of AI added to them. They don't need to always be this kind of big complex AI chatbot system. They can be quite small specific tasks. And the nice thing about those small specific tasks is that you can spend a lot of time tweaking that prompt until it works really well. And that way you can get kind of guarantee really good results. The problem with chat interfaces a lot of times is that they're dependent on the user having a really good understanding of how to prompt the system well to get a good result. And they're usually not very good at prompting, so they might not get the best result. So if you can take care of the actual main prompt and just let the user kind of add their little thing to it, you can usually get a much better result. All right, so let's take a look at another kind of real life situation. So right now we have a hypothetical pizzeria called Bob's Pizza, and we're so popular that we have so many reviews, we don't really have time to go through them all. So here we create a little analysis tool. So it's going to look at all those reviews and try to classify them as positive, negative, or neutral. So we can get a sense of like what type of review are these, which one should we kind of take action on. And okay, so let's say we can see there's a negative review here. Maybe we want to respond to them. So in this case, we're taking that review and we're creating a response template based on it. So whoever's working in our customer service can kind of get a starting point on where they could kind of start responding to that user. So in this case, I didn't spend a lot of time tweaking the prompt, so it's maybe a little bit too long in my opinion, but it's still a good starting point. So if we take a look at what this looks like in code, I'm going to close that. And we'll notice kind of a couple of interesting things here. So I'm not going to go through the UI code too much here because it's not the main part of this. And again, I will share the entire code base with you so you can play around with this as much as you want. What's interesting here is really like what happens when we analyze the sentiment of one specific review. In this case, since we are in a Java world, I want to take advantage of strong typing. I don't want to work with just strings whenever I can. So I've defined a record here called sentiment response. It takes in a data type of sentiment, which is a data enum that I have in Java. And then when I prompt the chat model here, I'm going to give it a Spring AI template. So you can see that there's this like variable in the template here for the review. So I'm going to say analyze the sentiment of the following review. Then I have some delimiters so that it knows that anything between those is the review. And then I pass in the parameter to the template. And then what's interesting here is I'm calling .entity. And I'm saying, hey, I want the response to be one of these records that I defined up here. So with that, what's going to happen is the Spring AI is going to append to the outgoing message a JSON schema saying like, hey, whatever you answer, it needs to follow this JSON schema. And when that comes back, Spring AI will transparently to us parse that schema into this record object. So for kind of from our viewpoint, we're actually using Java to input and output stuff to the LLM, which is super convenient for us. So we know that we're getting an actual sentiment here. So that way we can just update the sentiment there. The other prompt that we're using here is very similar. In this case, we have a system prompt that identifies this as a customer support representative at Bob's Pizza. It should be friendly and respectful. And then we create a text here that says draft a response to the following customer review posted by name and then the review itself. So here again, we're populating two parameters into the prompt and then we're calling, and that's going to give us back the draft that we're showing here. So again, to the user of the system, they're not kind of left staring at this empty text field where they need to prompt the kind of AI in the correct way to get useful things. They have a button here that says analyze, and in that case, behind the scenes, we use AI to analyze and do things. When we click respond, again, behind the scenes, the AI is doing things, but to the end user, that's not visible. To them, that it's just one of the many functions that this application has. All right. I just want to make sure we don't have any questions going on there. All right, very good. Good. Right, so the next thing that I want to show you is kind of taking things even one step further. So this is kind of getting into the territory where a few years ago it would have been very kind of hard to do this just in one sitting in a couple of minutes. So we're going to use an AI, a multimodal AI to actually extract data in a structured way from an image. So since we're at a jug, I created a little kind of hypothetical sign-up sheet for a actual in-person jug where people kind of sign in and put their email address and their t-shirt size and stuff. So if you've ever been to a jug, you probably filled in one of these at some point. The painful thing for the organizer is to like try to somehow get this list into a computer if they want to actually email these people. So let's take a look at a hypothetical AI augmented functionality where we could just drag this into our application here and ask the AI to look at the image and give us the information in a way that we can make use of. So in this case, we get all the same names that we have. Looks like everything got translated correctly, and we can sort and filter and do all the things. So now we have the data as actual Java objects. Now we can do stuff with it. We can send emails. We can persist them in a database. We can essentially do whatever we want. So let's take a look at how that might work in practice. So again, the actual UI code is not super interesting. What's interesting here is this. part where we actually call the AI. We have two records here, one for a single participant. So that's like one row in our sheet. So we have the name, we have the company, email, and t-shirt size, and then we have a record that corresponds to the entire sheet. So in this case, we have a list of participant records here. So what we do then when we call the AI is, again, we do client.prompt. So we create a new prompt, we add a new user message. This time we're going to do a message that has both text and media content. So the syntax looks a little bit different. So we use this lambda here, and we say that user message.text should be, please read the attached event signup sheet image and extract all participants. And then we add a media. We parse the MIME type from the upload, and we pass an input stream resource based on what we got from the upload. And then finally, we say, I want that as a sign-up sheet record. So again, what happens here is that Spring AI will append to that prompt a JSON schema saying that, hey, we want an array of these types of objects, which again, the AI can look at the image, it can see what data is in there, and then we can determine how it should fit into that schema. And it does a remarkably good job at that. So I've used this for scanning receipts, for sign-up sheets, for all kinds of stuff, and it just works remarkably much better than you would expect out of the box. So I would very much kind of encourage everyone to explore the possibilities here, where you can take something that's not digitized and actually make it available to yourself as job objects that you can do literally whatever you want. Good. So the next one I want to take a look at is calling functions. So just calling the AI is cool. We could give it very kind of instructions so we can pass in data. But in order to really integrate it with our system, it's very useful if we can give it a set of tools that the AI is able to call on its own to get more data, to kind of get up-to-date stuff from the database or update things for us. So in this case, I have a kind of a data grid here that displays some hypothetical products that we have here. This is just like a view into our database. It's not anything editable. What I have here on the side is a chat interface. And if we take a look at the implementation here, we'll see some pretty interesting things. So if we go to where we initialize the chat client here, you can see that we use the chat client builder the same way as we did before. One thing that's different here, though, is that we're calling this default tools and we're passing in a service. So in my product service, I've actually annotated a few methods as tools. So by adding this tool and giving it a description, this in itself is kind of a mini prompt. So you need to, again, try to be as descriptive as you can when describing these. Of course, if it's a very descriptive product function name, it might be able to use it correctly, but it's always best to give it a clear description of what it does. So by giving a tool annotation on a method, you can make those available for the LLM when you pass them in as tools here in the builder. The other thing to note here is that we've added this message chat memory advisor, and that's something that's built into Spring AI that allows it to keep track of the message history that we have going back and forth, because the LLM itself is entirely stateless. So the LLM does not remember anything from the previous time we called it. So if we called it with some information and then we referred back to our previous message, it would not know what we're talking about unless we always, on every call, send the entire message history up until that point. And that, of course, would be very tiresome if we had to do that ourselves. So fortunately, there are built-in ways for us to do that. So let's see how this works in practice. So let's see if it's actually able to call some of these functions. So we have the functions of finding all products, or finding one product by ID, or saving a product. So let's see that we want to get more information about product ID 5. Can you pull up 5. So hopefully what it's able to do then is it can look at the query here and it can determine like, I don't know anything about product 5 in my general training data on the internet. So this must be something very specific. Then it goes and looks like, what tools do I have available to me? And it sees like, hey, there's a find a product by an ID function here. That makes sense. Like, let's call that with ID 5. And then it actually calls our service and gets the data, which we can show here. And then because we have that chat message history there, we can now refer back to it. So we could say something like, write me some ad copy for an online ad or something like that. And then it'll kind of take the information that it has here and it can actually use that to update it. We could probably try to change it too. We could say like change the product name to Very Good TV. I haven't tried if this actually works, so we'll find out together. All right, so I actually don't have any method to actually refresh this, so we need to do a full refresh, but sure enough, it's updated in our database. So I hope it's quite obvious by looking at this that if you make a method callable from the LLM, you want to add some actual Java-based checks on what it's actually doing there. So probably don't do what I'm doing here and giving it like full access to my database, but give it very specific access to some tools, mostly read-only tools. And if you have any write tools, add some actual Java code there that makes sure that it's doing what it's supposed to be doing and not something that it's not supposed to be doing. All right, very good. Let's jump back to the slides for a little bit here and see kind of a little bit of background into the next section here, which is retrieval-augmented generation. Let me see, I think there's a question here for sentiment analysis. Sorry, so I'm taking a quick question here from Slater. For sentiment analysis, sometimes customers write whatever they want, such as shorthand, U2 or jargon. Should we clean the customer reviews before passing them or as they are? I think for the most part, they will work just as they are. The reason being that the LLMs in their training data have gone through most of the internet as it is today. So they will have run into all of this same jargon that the customers are using in the review. So I would start by just passing it in as it is and see what happens. For the most part, it's probably going to be just fine. It's going to do a good job. If not, then again, this iterative engineering loop kicks in and you start changing the prompt a little bit to see what works, what doesn't, how can I make it better? Good question. Thanks for that. All right. Sorry, I'm still a little cold from my last week's Dev Nexus. All right. So let's take a look at RAG. So in order to understand what retrieval-augmented generation is and why we would want it, we need to understand the general problem that we have when we're building specific business applications with LLMs. And that specific problem is that the LLMs in themselves are generic, whereas what we're trying to do in our own projects is very specific to a context. So there's a mismatch, kind of fundamental mismatch between how they work and how we want them to work. So let's take a look at how they work kind of under the hood a little bit and how we can improve the situation. So the one kind of key part to this puzzle is the context window. So you probably have heard of, even if you haven't worked with AI that much, you've heard about different context window lengths for different models and them getting bigger and bigger and bigger, and that somehow being good. The context window is essentially the working memory that you have available to you as you're working with the LLM. So it's like your RAM, if you will. It's important because it needs to fit everything that you want to have available to that discussion, including the actual answers that it's generating. So you have a limited amount of this. Now, these days, you're not that limited. Many models have windows up to like 1 million plus tokens. So that means that you have probably more than enough space to actually fit that in there. The problem is that the providers are still charging us by the amount of tokens that we use. So we have a kind of a built-in incentive to try to be mindful in how we use this. So what we need to fit into this prompt is, first of all, our system prompt. So this is us telling the LLM how it should look and behave. The second thing we need to fit in there is the entire chat history in some way, shape, or form that we want to have available to it, so it understands the kind of historical context to our discussion. Then the current prompt, and very likely some relevant information that we want to give the LLM that helps it answer our question. If you're using very small local models, this might still be an issue today. Most likely it's not. But you want to make sure that, like, after filling in all of this, you still have enough kind of empty space, if you will, in your context window where the actual response can be generated. So again, not usually a problem these days. 2 years ago, it was a much bigger problem. So in order for us to understand how we can make the LLMs aware of our context, we need to understand kind of what it already does know or doesn't know. So generally, they know two things. The models know all the content they've been trained on, which is more or less the entire internet up until a certain point in time. So it has a very vast set of knowledge in kind of general knowledge. The other thing that they know is whatever you pass into them using this context window that we're just looking at. So if you want to teach the LLM new things, you have a few options. One is to train your own model. So this is super great if you have a couple $1 billion of extra money laying around, very much time, a couple of months maybe to train one these days. So probably not very viable for most of us on this call. You could fine tune a model, meaning you take an existing general purpose trained model, say Llama, and then you start giving it concrete examples that are relevant to your business. So you can say, like, hey, if somebody says this, then answer this. If they say this, answer that. This is something that's not terribly expensive or difficult, but it is time consuming and kind of takes some effort and time still. So it's not super expensive. But again, there's an even easier way we could do this. And that is to figure out what's the most relevant piece of information to give it as part of this context to answer whatever the user is asking at this point. And this is where retrieval-augmented generation comes in. So how can we retrieve relevant information to augment or give to the LLM in order to answer a question? So that gets us to the kind of underlying question of how do we determine what's the most relevant piece of information that we could give it. So in this hypothetical example, we have a small document with 3 paragraphs. It's a terms of service document for a hypothetical company. And what we want to do then, in order for us to make this available for kind of easy search for relevancy, is first of all, figure out a way to split this into meaningful sections. So in this case, our document has kind of clear semantic meaning to it. We can see that there are numbered sections and stuff that we can use to split this. In other document types, you might not have as clear kind of demarcations of what's kind of relevant to what. So you might need to just figure out other ways. There's a ton of literature on chunking strategies, on how to do this. But for the sake of this example, we're going to split by section because we know that each section is about one specific thing. We then call something that's called an embedding model. An embedding model is something that takes in a string and gives us a vector representation of the semantic meaning of that. So that's a little weird as a concept. So we're passing in any kind of text and we get something that represents its meaning. To make it even weirder, it should be more or less the same vector value, regardless of if the input is in English or in Spanish or another language. So it's really trying to capture the underlying meaning, not the way it's expressed in a specific language. So to try to kind of illustrate what this means in terms that you probably have run into earlier, I like to use an example of a color picker. So a color picker does a very similar thing, where it allows us to pick one specific thing, a color, and it gives us a corresponding vector value. In this case, the vector value has only 3 values, so it has a red, green, and blue value. Intuitively, we know that if we pick 2 colors that are very similar or kind of close to each other, their vector values will be very similar in numeric value. And similarly, if we take 2 colors that are very far apart, say blue and red, their vector values will be very far from each other. So essentially what we're doing here is we're taking that same concept, but we're just applying it to text instead of a color. And that's why it's important for us to try to chunk the text here in meaningful chunks. So by doing that, we're able to ask much more specific questions. If we didn't split the document before running, essentially taking these color values, it would be like asking the color for an entire image. It doesn't make as much sense. You could definitely kind of measure some sort of medium value of all the colors in the image, but it wouldn't be very specific to what you're actually asking for. So if you're able to ask something more specific, like what's the color of my t-shirt that I'm wearing, then it's able to give you a much more specific answer. So similarly here, if we're able to have semantically meaningful chunks, we can ask much more better questions to get those. So again, the values that we're getting from this API that we're calling are not going to be 3 values. They're going to be 1,500, maybe 3,000 plus dimension vectors. Each vector value there measures how similar those texts are in some way that we don't, as humans, necessarily know. But we know that if we do a dot product or a cosine product of those vectors, it's going to measure how close they are in relation to each other. So once we have the text, we have their vector values, we're going to put them into a vector database. This vector database is a database that's good at vector math. And once we have them there, we're able to do something pretty cool. So if a user now comes in and asks us a question, we can take that question and run it through the same embedding model, which would give us a vector that represents its meaning. So in this case, if the question is, what's the cancellation policy? We can understand that kind of intuitively that this vector somehow represents the meaning of cancellation. However, that's represented in numbers. So then we go to our vector database, giving it this vector saying like, hey, give me the most similar documents you have in meaning to this. So what are the things that are most related to cancellation that you have in there? Given that we only have 3 documents here, it shouldn't surprise us that we're going to get the cancellation policy part of our document as a result of that as the most related document. So what that allows us to do then is we can construct a prompt that not only has the original question, but we can give it context now saying answer using these provided documents. So this is very similar to, if you ever remember in school, those few lucky times you had an open textbook test where you could actually have the textbook open while you were answering the question. And it became almost too easy because literally you can just copy over the answer from the textbook. So we're doing the same thing. We're giving it a question and also the textbook open on the right page for answering it. And by doing this, it becomes really, really good at answering questions, even though it hasn't been, like the underlying model hasn't been trained on this data. But if you're able to provide it in this prompt, then it knows that data and it's able to actually give a really good answer based on it. So let's take a look at what that looks like in actual code terms. So we have a set here, and I have a little button here where I can add some context to it. But let's ask it a question without any context and see what happens. So the context that I have is very meta. It's the Spring AI documentation on retrieval-augmented generation. So this is something that's really new. So it's not going to be in any models based training. So if we ask about, say, something that is in here, let's use this retrieval augmentation advisor that's incubating. So it's literally, this came in, I would want to say 2-3 weeks ago. So it's definitely not in GPT-4o's training data. So tell me about. So we're asking it something that it has no idea about. Right now, it's going to think about it, and then it's going to say, not a widely recognized concept or product as of October 23. Based on the name, it might refer to this or that. So it's giving it a try. It's like, hey, it might be this, might be that, who knows? But it's not super helpful to us. So let's see how it behaves if we actually do give it some context. So I'm going to open this. I'm going to drop in my file here, and then we're going to see how it responds to that. So let's see, tell me about. All right, so now that we were able to give it the correct parts of that document as supporting material for this, it's going to make a very big difference here. So now you can actually see it's an experimental feature in Spring AI, provides out-of-the-box implementation for common retrieval-augmented generation flows, uses this and that. So we're actually getting really relevant information here. So let's take a look at how that's actually implemented. So this is a little bit more code, and I've added a lot of comments here just to make it kind of clear for you, because I've added many more steps than you might use in a normal one, just to kind of show the possibilities that we have here. So again, we're using the chat client builder here. We're creating, defining some advisors. These are essentially like filters that get applied, or sorry, like interceptors that are getting applied to the calls as they're going out. So we have the message set memory here, but then we're defining a RAG pipeline here. So it comes in essentially a few parts. So we have a pre-retrieval stage. So what do we want to do before we go and find documents? Then there's the actual retrieval, and what do we do after we've retrieved? So we have different stages here. So pre-retrieval, I want to first call a compression query transformer. So this is maybe a little bit abstract, so I tried to give an example. When you get kind of further along in a discussion, a follow-up question will often not be specific enough to be very useful for doing that vector search. So imagine if we had been discussing about something and then the user asks, what are the benefits? Now that in itself doesn't really convey a whole lot of meaning, because we don't know benefits of what, like the message in itself doesn't contain enough. So what the compression query transformer does is it looks at the history and tries to create a standalone question based on that. So it will look at the history, and then it will create a new variant of that that contains the relevant information. So maybe the actual discussion was about exercising, so I would rewrite that to what are the benefits of exercising. So now we have, again, a standalone question that would be meaningful to run through that embedding model to get values out of that vector store. Whereas if we had sent this to the vector store, it would have just given us a shrug emoji because it wouldn't really have any meaning. Then another thing that we might want to do is rewrite the query for kind of conciseness and clarity. So maybe the user had a long story. It's like, I've considered starting to run, maybe lift weights. Are there benefits to this or that? Again, that's unlikely the way that it's expressed in the documentation. So we have a transformer that will transform the query into a format that's more likely to be kind of matching in semantic value to a vector store. So again, it might rewrite that again to what are the benefits of exercising, which would be something that would be more matching in our thing. Another really kind of exciting step we could add is a query expander. So sometimes the one specific query the user asks is not kind of enough, or it wouldn't allow us to get enough kind of breadth of information to answer it well. So we could expand that query. We could ask it an AI to kind of expand on it and figure out what are some related things that would be interesting to know. So if the original question was, again, what are the benefits of exercising? Maybe we would expand and also ask, what are the benefits of cardio or strength training? And by asking all three of these questions from the vector database, we'd probably get a more diverse set of documents that we could pass in this context. Then the actual retrieval from the vector store is quite trivial. So we say that we want to have a vector store document retriever. We pass in the vector store that we've injected here. So if we look at where we've instantiated our vector store here, so in this case, I've created a bean that has a vector store that's of simple vector store type. So this is just an in-memory one. The nice thing here is that this is an interface. So whenever you do go to production, like I just over the weekend, I built a system with Pinecone. It's the exact same API. So I could start with an in-memory one, and then I just switched out the implementation to an actual one when I wanted to actually start going to production. And then finally, once we've gotten all the documents from there, we have this contextual query augmenter, which takes all the documents that we got from doing all these steps, and it appends that to the actual user query and builds that final query with the question. And here are the relevant answers for answering it. The part we didn't look at yet is how do we actually get things into the vector database. And that is over here. So that's surprisingly simple. So again, we have that vector store that we had, and we're gonna use it to call write. And what we're doing most internally here is we're using a Apache Tika document creator, which is able to read pretty much any document under the sun. We're taking the output of that and passing it to a token text splitter. So this is one way of splitting up that document into meaningful sections. The token text splitter essentially tries to use a certain number of tokens as the splitting delimiter. There are different splitters you could use, like if you had, say, markdown content or something that has more semantic information to it, you could probably use a more specific splitter and get better results. But for the demo here, this works well. So we read the document content into text, we split that text into chunks, and then when we call write here, that's going to run each segment through that embedding model and save it into the vector store. So, and again, I didn't mention, but I kind of briefly touched on it here. When we define the vector store, we give it an embedding model, so it knows what is the algorithm for taking a text chunk and turning it into a vector. So when we upload, we write things into the vector store, and then as the user message comes in, it goes through this entire pipeline where we transform the query first into a more meaningful way, and then we ask some relevant kind of other questions, and then finally we go to that vector store and get it, and that way we can get this. So it's unfortunately a little bit more code than I had hoped to just like lay out on you, but I think it's more important that I was able to kind of walk you through it once and then give you again this link to this so you can then study it on your own. So if you do want to play around with this project on your own, you can find it in my GitHub. There's also a QR code that I hopefully made correctly and goes to the right place. If not, this is at least the right URL here. So let me see. I can, or maybe one of the organizers can paste it in the chat so everyone gets it from there. All right. I want to be mindful of our time, so I'm going to just quickly go through the next section just in a couple of minutes, and then we'll wrap up. And if there are any questions, people can stay on for a couple of more minutes, and I'm happy to answer questions.
Thank you, Marcus. Thank you, Marcus, for your presentation.
I still have one more topic, if you don't mind.
Oh,
so
right.
Just like
okay.
2-3 minutes.
Okay.
But you're
go ahead.
Yeah.
Go ahead. Thank you.
Yeah. So one of the things that a lot of people ask me when I talk to them is that, yeah, this is all cool, but my company says that we can't send anything to these external providers because we're working with some internal stuff. Like, how can I work with that? So fortunately, there are a lot of local models that you can run these days, which obviously they're not going to match the big models in performance all that well, but especially if you're using RAG and you're able to give them enough context, they're doing a remarkably good job. So if we take a look at some of these tools that we have available, I have two personal favorites, LM Studio and Ollama. Ollama is probably the kind of widest used one. So it's a tool that you can use to run models locally. and essentially serve them on a OpenAI compatible API. So that way you can use them pretty much the same way as you could OpenAI models. LM Studio is a Mac and I think Windows Linux project that in addition to having a server, it actually has a chat window, so you can ask questions like, how do I create a hello world in Vaadin? And then it's, in this case, I'm using a local model with Qwen 2.5, and it'll give me. So it looks and behaves kind of very similar to a OpenAI model. It's not as good quality, but it's remarkably good quality. What's interesting then is that if we have a local server running with either of these tools, the only difference is the port that they're running on. We're able to go into our properties here, and I've actually left these commented out. So you can comment out the OpenAI ones, and you can comment in these ones. So in this case, I'm using LM Studio, which is port 1234. Olama has, I think, 11234, maybe something like that. Then you just pass in whatever the local model names you have, like this, and go ahead and start. Because both tools have a OpenAI compatible API, you're able to actually use the exact same code everywhere else. So you don't have to change any of your actual implementation code to switch between local and cloud models, which I think is pretty cool. Like, so tell me a cool fact about Peru. All right, so now we're actually calling a local model instead of OpenAI, and it's still behaving the same way. So just wanted to kind of highlight the possibility that, yes, you can still do AI development, even if you're not able to access outside models. When you go into production, there are local clouds. This was a picture I took during our conference in Frankfurt. We were literally in a local cloud. It was very, very very foggy there that morning. But what I wanted to say is that a lot of cloud providers now let you spin up your kind of local or own private instances of LLMs, even of some of the bigger models. So you could, through Azure, you could get some OpenAI models for private use where you're not actually sending it outside of your kind of control in the same way as you would to the public API. So that is it. Now, now I'll shut up and let you guys ask some questions. All right. Good. I'll.
I have a question for you. It's,
Yeah.
I don't know if you're aware about MCP protocol introduced by Antrofit.
Yeah.
What do you think about it?
I think it's really good. I actually 2 weeks ago I wrote MCP server for Vaadin. So if this looked like cool code to you and you want to use it, then you'll notice that many of the models will have slightly outdated information about using Vaadin. But if you connect the Vaadin MCP server to it, it's able to actually fetch, doing very much the kind of similar thing that we did with RAG, but over the server. So it's able to actually pull relevant piece of documentation into its chat and understand more about Vaadin development. So I think it's really good to have like a beginning of a standard for actually providing context to models, because we can definitely see that if we're able to have more relevant information in that context window, even a smaller, simpler model is able to perform really well. So if we have standardized ways to provide more and more information, I think we're able to do really cool things.
Yeah, exactly. Okay. I think there are no more questions.
All right. Well, I mean, like I say on the slide here, if you have any questions later on and you want to reach out to me, you can find me on socials. Always happy to have a chat. And otherwise, just thank you a lot for having me. It was fun to spend a little afternoon here with you.
Thank you, Marcus, to join us. What very appreciated to have with to share your story with us, with a community team. Peruvian community is very interesting to know more about AI technologies. It's a future of development probably when we probably transformed the software engineer role to AI software engineers or something like that.
Yeah.
We'll see in the future. Thank you, Marcus. Thank you to join us. Bye.
All right. Thank you, everyone. Have a good evening. Bye.
Good evening. Bye bye. Chao, chicos. Muchas gracias por unirse. Ha sido Marcos con nosotros. Hasta una siguiente oportunidad. Muchas gracias. Chao.